Hey guys, welcome back to another video. In this video, we'll be working with Leetcode problem number 16 that is called 3 sum closest. And so without any further ado, let's get right into it. So the point of this problem, as we can see in the description, it says, given an array called nums of n integers and an integer called target, find 3 integers and nums such that the sum is closest to target, and then return the sum of those 3 integers. You may assume that each input would have exactly one solution. So looking at the only example that they gave, we have nums is an array -1, 2, 1, comma -4, target is 1, and we have the output 0, since the sum that is closest is -1 plus 2 plus 1, which is equal to 2. And so since 2 is closest to 1, we have to return the 2. So that is a very short description. I think it's pretty understandable. And without further ado, let's get into the first. Let's think about how the step-by-step process for solving this question, and then we can get to the coding aspect of it. So the first thing I'm going to do, I'm just going to copy this example that they gave here. Call it nums is equal to, I believe it's -1, 2, 1, and a -4. And then our target is equal to 1. So the very first thing we should do is we should run nums.sort. So that what this does is it puts the array in numerical order, so that when we traverse the array and we need to calculate targets and things like that, it's going to be easier for us to traverse and go through the array in a way that we don't really have to go back or worry about missing a certain number or anything like that. So the first step would be order the array, right? So what would that return? That would mean nums would now be equal to -4, -1, 1, comma 2, and our target is still going to be equal to 1. So now we've ordered the array in the way that we want it to, and before we continue, I want to first see what's the last number that we will need to run through. And so what I mean by that is we know that in order to return a sum of 3 numbers, we need to first at least have 3 numbers in our array so that we can return that sum. And if we don't, we can just return 0. And if we do have 3 or more numbers, I want to calculate the index at which we can just stop, because I don't want to, once we traverse our pointer to get to a point where the rest of the array is just 2 numbers or less, we can just end right there, because we know no matter what subarray we get, that's only going to be 2 elements or 1 element. That's not going to be 3, and so it's not even a valid check for us to do. And so what I'm thinking is, first I want to count the indexes. So -4 is index 0, 1, 2, 3. So we know that our last number is of index 3 and our nums array is length 4. And the last number that we can check is going to be this 1. And the reason that is once we check the -1, we could run -1 plus 1 plus 2. And once we get to this 1 over here, then there's no point of checking, because only numbers we could sum up are 1 and 2. And so that means that our index, which I'm just going to call I for now, our index has to be less than the length of our nums minus 2, which in this case is 4 minus 2, which is 2, right? Because what we want is that we want our index pointer to be before this pointer right here, this index, so that once we get to this index, we can just return whatever target or sum we have up to that point that's closest to, whatever sum we have that's closest to the target that we have at that point. And so that's going to remove any extra iterations that we don't even need to handle for. And so that is the first step, ordering the array and seeing how far we need to traverse. And now let's go to the part where we actually need to traverse the array. So I'm going to copy the array again, -4, -1, comma 2. And I'm going to have a counter over here, which I'm going to call sum. I'm going to call sum closest. And what this is going to be the sums that we have that are closest to the target as we go along. So the first thing I want to do, we want to first start off at this big number over here, this -4, the very first number. And what we want to do is, since we have this -4, we want to traverse the rest of this array and add those up to the -4 to see how close we get. If you remember one of the earlier problems we did, there was a easier version of this problem where we had something like -2, 4, 8, 10, and we were told we want to traverse this array and find the closest number that's equal to that of sum that's closest to a target. And what we did in that case was we had 2 pointers at the start, at the end, and if our sum was less than the target, then we moved our start pointer over. If our sum was bigger than the target, then we moved our end pointer backwards. And so what that did was we started off with 2 pointers and they converged closer and closer, and until they met or we got to the target, we kept traversing so that we got at least the sum that was closest to the target, if not the sum that is equal to the target. So this was with just 2 pointers. This very similar concept is gonna apply in this inner loop. And so let me actually erase all this. Let me use this type of eraser so it's a little easier to get rid of all this stuff. So what this means is we have our -4 and now we have this subarray over here. So I'm going to call this pointer the S for start and this pointer E for end. And what we're going to do in our first step, we're going to add -4 plus -1 plus 2, which is going to be equal to, what's that, -3, I believe. Yeah, that's -3. And so what this means is we have this sum, it's -3. Since we haven't found any other sum yet, -3 is going to be closest to our target 1. So for now, I'm just going to have -3 over here. And now we want to check if this sum is less than or greater or equal to the target. We obviously know this isn't equal to the target, and we realize that this sum is less than the target. And so what we're going to do, we're going to move our start pointer over here. So I'm going to cross this out, and our new start index is over here. Now we're going to calculate again. And mind you, all this is while we're making sure that our start index is less than our end index. Because we have to make sure that even if they do collide, if the start and end index are the same, that's not allowed to happen because we can't add the same number twice at the same index. They have to be two numbers from two different indices. And so we want to make sure our start is less than our end. And over here, we moved our start pointer over, and now we're going to do the calculation again. We have -4 plus 1 plus 2, that's equal to -1. Now we have our new sum -1, and -1 is closer to 1 than -3 is. So I'm actually cross this out. I'm going to write -1. And at this point, we know that if we move our start pointer over, since -1 is less than 1, if we move our start pointer over, it's going to be equal to our end index. And so we're done with that iteration. We're done with working with number 4, and that's it. And so now we can move on to -1. And so let me erase some of this up to make it a little easier to understand what I said. So now we worked with -4, we traversed the subarray, we calculated sums, moved indices as we needed, and now we're going to move this over, and now our big pointer is going to be at the -1. And so I'm going to draw a little dashed line. And so now our subarray is right over here, right? So in this case, we have -1. Our start index is here, our end index is here. We're going to have -1 plus 1 plus 2, and that is going to be equal to 2, right? And 2 is closer to 1 than -1 is. So again, I'm going to cross this out. I'm going to replace this with 2. And if we move our if we actually move our end pointer backwards, since we know 2 is greater than 1, if we move our end pointer backwards, then that's going to force start to be equal to end. And we're done with that iteration with -1, since that's the only case we need to make sure that we're accounting for. But since start is equal to 1, we're done handling for -1. Start is equal to end, we're done handling for -1. And now that that happens, we're going to move I'll do this up here. We're going to move our big pointer over. So we went from 4 to -1 to 1. But if you notice, we said over here that our I should be less than len nums minus 2. And so that means we shouldn't be checking this -1 because we can't even look at 3 elements at a time since there's only 2 left. And so at this point, we can just return whatever our sum closest is, which is 2. And so at the very end, we'll just return our sum closest, which is going to be equal to 2. right? And so that's going to be our answer. And that's how we need to, that's some of the steps that we need to do to get to this answer. One thing we should note is that to make our the process more efficient, since we did nums.sort at the beginning and we created a sorted array, one thing we should handle for is, say we have -4, -4, -4, and then 1, comma, oh, sorry, then -1, comma, 1, comma, 2. So if you remember, we had this, we start off with -4, and this is our subarray. Say we have our start pointer here and our end pointer here. We do our math, we get our target, which is something, I believe in this case it's -6, -4, -8, so -6, yes. So this is our first calculation, and we know that we're going to have to move our start pointer up. Imagine this is a brand new problem, and this is a new array that we're given. We did the first calculation, we know we have to move our start index up. One thing you should notice is that our next index is the same as our previous index, right? -4 is going to be equal to -4. And one thing we can do, we can keep checking to make sure that our current number is not equal to our next number. And the reason we do that is so that we don't keep calculating the same things again. In this case, if we didn't do that, we do -4 plus -4 plus 2. We'd have to do that twice. But since we handle for checking that our next number is not the same, we're only going to be doing unique calculations every time, and that's kind of what we want to do to make our algorithm more efficient. And of course, if we're traversing the array and we get to a point where we do find 3 numbers that equal the target, we're just going to return the target at that point. So that's something important to note. And so that is the gist of some of the steps that we can do to solve this problem. I actually have editor open here. I'll copy the code into Google Doc to share with you guys, but I thought it'd be a little easier to copy and paste as well, so I'm just going to do it over here. So referencing back to where we started, the first thing we said is, before we do anything, we should always check for base cases. So what I'm going to say is, if len nums is less than 3, I'm just going to return 0, because in that case we can't even get a number that's closest to the target, or we can't get 3 numbers that we can sum up to see if it's closer to target. I believe we have to return 0. We might have to double check that, but for now that's just the base case that we have to handle for. So this is our base case. The next thing we want to do is we want to sort our nums array, right? So that's easiest for us to traverse, and so I'm going to say nums dot sort. And the next thing I'm going to do, I'm going to have an index called I, which I'm going to set to 0. And what this is going to do, this is going to be that outer pointer that we moved from -4 to -1 to 1. That's going to be that outer pointer for us to check. And so that is the index. The next thing we want to handle for, or we want to create a variable for, is going to be our sum closest, which I'm going to equal to float -infinity. This is how you can initialize a variable to -infinity in Python. And what this does is, right off the bat, whatever difference we get, it's always going to be closer to our target than -infinity. So that's why we initialize this to -infinity. And so now what I'm going to do, I'm going to say while I is equal to len nums minus 2. Remember, we're looking at len nums minus 2. And what I'm going to say is, let's look at it. So we have our big pointer. I'm going to first create an indice called start, which is going to be equal to I plus 1, and another pointer that's going to be called end, which is going to be len nums minus 1. And so those are going to be our 2 pointers at the in our subarray. That's going to be that called start and end. If you remember the S and E, those are what those 2 pointers are. And what I'm going to do is I'm going to say while start is less than end, our sum is going to be equal to nums I plus nums start plus nums end. So what this does is, this is the target, this is this calculation over here, and now that we have our sum, we want to compare it to our closest sum, our sum closest. And so what we want to say is if the absolute value of our target minus sum is less than our sum closest, then, well, first of all, we should actually check if our sum is 0, right? If target minus sum is equal to 0, then we just want to return our sum, right? And so that's that case. And the next thing we want to check is if our difference is smaller than the closest sum that we have. We're gonna say sum closest is equal to our sum, right? Because our difference is closest to, or actually this should be absolute value of our target minus sum closest. And so what this does is it takes two differences, and which if our current sum, if the difference of our current sum is smaller than the difference of our previous closest sum, we're just going to replace our closest sum with the sum that we just calculated. Now what we want to do, we want to move our start and ends pointer as needed. And so what I'm going to say is if sum is less than target, that means we need to move our start pointer over. I'm going to say while start is less than end, and our nums start is equal to nums start plus 1, start plus equals 1. And after that, we also want to say start plus equals 1. And so what this does is, if we looked at this example here, we had our start pointer over here. We checked if it's equal to the number after. It was, so we moved our start pointer over to here. We checked if it's equal to the number after. It's not. And so one thing we do need to do, we need to make sure we move our start pointer over one more time to make sure that that we do look at a new number or a different number to find a sum. And so that's the case if our sum is less than our target. If sum is greater than our target, it's going to be the opposite, where we're going to say we're going to be moving our nums end is equal to nums n minus 1, n minus equals 1, n minus equals 1. Right? And so then we're going to go back around and we're going to check while start is equal to end, do our new calculation, and do all this. And so now what we want to say is, once we've traversed all this and we've gone through all this, we want to do a similar kind of calculation in the outer, I guess, the bigger pointer or the outer pointer. And so what I mean by that is we were checking if the start index is equal to the start plus 1 index. We need to do the same thing for this outside index, this nums I, or our I pointer. And so we're going to say while I is less than len nums minus 2, and nums I is equal to nums I plus 1, I plus equals 1, I plus equals 1. And so what this does is it keeps the same, it keeps moving our I pointer along so that we can make sure that we're looking at a new number instead of, in this case, if we were looking at our I pointer over here, instead of looking at -4s only, we make sure we look at a -1 at some point. And so that should make sure we're always looking at a unique number. And at the very end, we are just going to return our sum closest. Now, I believe that is all we handled for, or all the steps that we had. One thing I am thinking is, if we can make this a little more efficient, instead of having a while loop, if we can add this up here, so that it might be better. What I'm thinking, we can do this. Instead, we can say if I is greater than 0 and nums I is equal to nums I minus 1, I plus equals 1, continue. I think that might be a better implementation of this. So what this does instead is, if we have our I pointer over here, let me go down to this. Let me actually copy this array. Imagine we have the same case, -4, -4, -1, 1, 2. Imagine our start point, our big pointer, I'll call I, is over here. Then we know that this is 0, 0, 1, 2, 3, 4, 5. These are the indices that correspond with the respective numbers. So we know that this is our index over here. Once we've run through this, if I is greater than 0, we want to check if the number is the same with the number before. And so imagine instead of our I pointer being over here, imagine I pointer is over here. We want to check if I is equal to I minus 1. If it is, we're going to increment our I pointer. Again, we're going to check if I is equal to I minus 1. It is, so we're going to increment our I pointer again. In this case, I is not equal to our previous pointer, or to I minus 1. That means we're just going to leave our I pointer over here and do our calculation starting with this I pointer and our subarray being 1, 2 in this case. And so what this does is, if our current number is equal to our previous number, we're just going to increment our I pointer and continue. And so that's not going to, if we do continue, it's not going to go through all this code in the rest of the while loop. It's just going to continue on to the next iteration. And so it'll check again, make sure I is less than len nums minus 2, and so on. We keep doing this process until we either do return essentially the target, or we just return the sum closest. And so I believe one thing I do want to check to see is if, okay, so we didn't even have to handle for the base case. The base case lets the nums array be at least of length 3. So I'll actually comment this stuff out. Sorry, that looks a little weird, but I commented out both lines of code. And so we stored an array, we have our index, we have our sum closest, we have while I is equal to 0, if I is greater than 0 nums I, that's to traverse and make sure we don't go over the same one. We have a start index, end index, we calculate our sum. If target minus sum is equal to 0, then we're just going to return the sum. If our absolute value of target minus sum is less than the absolute value of target minus sum closest, I'll say over here, if sum closest is equal to float negative inf, or, and so what this does is, instead of having to calculate target minus infinity, because we already know that infinity as, or minus negative infinity, we already know it's really far away, we can always, we're supposed to replace sum closest on our first iteration. I'm just saying if it is equal to that, then we can just replace our sum closest with the sum. And so, but if that is not the case, we do target minus our current sum. If that difference is less than the one with our current sum closest, then we're just going to replace our sum closest. And then we're going to move our start and end pointers as needed. Do that. Also move our end pointers if needed. And then move back up and check if our current number was equal to our previous number. If not, we're going to increment, do this all the way until I is equal to len nums minus 2. And then at the very end, we're just going to return our nums closest, or sum closest. And so what I'm actually going to do is I'm going to run this on a couple of the tests, or at least the one test case that they gave in the Leetcode problem, which I'll just copy and paste. I think I need an extra, yeah. Okay, so I'm gonna run Python ld16.py. Okay, so this is, we entered a while loop. So that means at some point we, oh, we never incremented our I pointer at the very end here. I plus equals 1. So we always have to make sure that since we're not doing enumerate, we need to increment our I at the very end. And so that is something we forgot to do. And if we run this again, we return 2. So that's supposed to be the right answer. And actually, the next thing I will do is I'll copy and paste all this code into the Leetcode editor over here. Okay, and I'm going to create a couple other test cases just to test it out to make sure it is working properly. So we'll try -5, -5, 4, -1, 6, and say our target needs to be closest to 3. And try one more with only 3 numbers, -1, -1, -1. I want that to be closest to -2. These are just random arrays, that random test cases that I'm making. And so I believe, let me run the code. Hopefully it should run all pass all those test cases. It does. So we get all the answers that we wanted. I'm going to run this and hopefully it'll pass all the Leetcode tests in the back. And so it does. And that's good news. So this is how we can code up the three-sum closest, I think is called, problem in Leetcode. Hopefully this helps you guys, and see you guys in the next one. All right, later.